All right. If you're working with Retrieval-Augmented Generation, you've probably been using vector databases for a while now. And if you have, you've also probably hit a wall when you're dealing with really complex professional documents. So, this explainer is a technical deep dive into a totally different way of thinking called PageIndex, one that moves beyond vectors entirely. Let's get into it.
This right here, this is the fundamental problem, the thing that frustrates so many of us. Traditional vector-based RAG, it's all built on this idea of semantic similarity. But what we actually need to get accurate answers is relevance. And as you can see, they are absolutely not the same thing.
So let's talk about that for a second. We've all been there with what the PageIndex team kind of jokingly calls vibe retrieval, right? You get results that are semantically similar. They've got the same keywords, the same general topic, but they're not actually relevant to your complex multi-step question. And that happens because similarity search, at its core, just can't reason about a document structure and its content the way a human expert would.
Okay, this slide really lays out the two different worlds perfectly. Over on the left, that's our familiar vector RAG. We have to artificially chunk up our documents, embed them, and then just cross our fingers that semantic similarity gets us close. It's often this opaque black box process. But then look at the right. PageIndex. It's built on reasoning. It uses the natural sections of a document, which means, and this is huge, no more artificial chunking. And the results? They're traceable, they're explainable, because it's not about vibes anymore. It's about logic.
And that brings us to the real core idea behind PageIndex. This is a fundamental shift, We're moving away from vectors altogether and into a system that actually tries to simulate how a human expert would navigate a dense document. It's all about letting the LLM think and reason its way to the answer, not just match some keywords or concepts. So this is the key definition right here. A reasoning-based RAG like PageIndex builds a hierarchical tree index. You can just think of it like a super-powered, intelligent table of contents that's built specifically for an LLM to read. The model can then perform what's called an agentic tree search, basically navigating the structure all on its own to find the precise context it needs.
Okay, so how does this tree actually work under the hood? Well, it's not magic. It's a really clever two-step process that is the absolute core of the PageIndex engine. Let's break down exactly how that works.
And here's the workflow, plain and simple. Step 1 is all about ingestion. You generate that hierarchical tree index from your document. That's a one-time thing you do for each document. Then, step 2 is retrieval. The LLM agent dentically searches that tree, reasoning its way through the branches to find the answer to a user's question. That's it. It's simple, it's elegant, and it is really, really powerful.
So, you might be wondering, how is this tree even generated? Well, for structured documents like Markdown, it's actually beautifully straightforward. PageIndex just uses the document hierarchy that's already there. A single hash, or a chapter title, becomes a level 1 node. A double hash, a section, becomes a level 2 node, and so on. It's leveraging the structure you've already created, instead of just blowing it all up with chunking.
And here's what that actually looks like in practice. This is just a little snippet of the JSON output, and you can see it's a really clean, nested structure. Every single node has a title, an ID, page references, and even an LLM-generated summary. This is literally the map that the LLM uses to navigate your document with surgical precision.
Okay, so now that we've got the core mechanics down, let's look at some of the more advanced capabilities. Because PageIndex isn't just a cool theory, right? It's designed for practical, real-world deployment, and it can even handle complex formats with amazing features like Vision RAG.
Now this is a total game changer. I mean, for anyone who's ever wrestled with flaky, flawed optical character recognition, OCR, this is huge. Vision-based vectorless RAG works directly on the PDF page images. It completely bypasses traditional text extraction, which means it can preserve the original document hierarchy just from its visual layout, something OCR almost always messes up. And what's great is you have options for how to use it. You can self-host everything using the open-source Python SDK, which gives you full control to run it locally, experiment, and develop. Or, for more enterprise-scale stuff, you can integrate it via their cloud service using the API or their MCP, the model catalog and platform, for a more managed plug-and-play solution.
Getting started on your own machine is incredibly simple. I mean, this is the command. You just run the script, point it at your PDF, and that's it. It kicks off the whole tree generation process. It's really designed to be super accessible for developers who just want to dive in and start playing around with it right away. And of course, being a developer tool, you get fine-grained control over this whole process. You can tune these key arguments to optimize for your specific documents.
For example, you can adjust the tree's granularity with max pages per node if you have a dense technical manual. Or you can toggle the LLM-generated summaries on or off to add more context to each node. This is how you really tailor the index to your exact needs.
So this all sounds really great in theory, a reasoning-based, vectorless RAG that acts like a human expert. But does it actually work any better? Well, let's take a look at the data.
98.7%. That's a pretty impressive number to just see on a screen. But what does it actually represent? What are we looking at here?
Well, that is the state-of-the-art accuracy that PageIndex achieved on the Finance Bench benchmark. And this isn't some simple test. Finance Bench is specifically designed for analyzing super complex financial documents like dense SEC filings. In a field where precision and reasoning are absolutely critical, PageIndex just blew traditional vector RAG systems out of the water. The proof really is in the performance.
And that brings us right back to the final and most crucial question. We started this whole thing with the idea that similarity is not the same as relevance. So I want you to take a hard look at your own RAG pipeline. Is it built on a foundation of fuzzy similarity, or is it capable of the kind of deep structural understanding that leads to true relevance? It's definitely something to think about. Thanks for joining this deep dive.